As interest rates continue to stay relatively low, the building industry continues to boom. Over the past year, traditional building materials costs and supply have soared and plunged like a roller coaster ride. One system that's seen gradual growth over the past 3 decades may provide another opportunity to build sustainably today and for the foreseeable future. That system is insulating concrete forms, or ICF. Climate change is forcing us all to change how we build just about any building or structure today. It's all about meeting the goal of net zero energy while meeting owners' performance requirements. The evolution of building codes is moving in a step process, and the language we use today to quantify our success is evolving right along with it. We've gone from referring to R values like R12 to R20 BAT to RSI 2.1 to RSI 3.5. Effective R values like home building has not changed for a very long time and has not changed much in 200 years, from balloon framing to platform framing. The only significant change has been the change from R12 to R20 BAT. The STEP process mandates incremental improvements over traditional values with the ultimate goal of net zero ready by 2032. That means houses built in 2032 on average will need to be able to meet their own needs. What do we mean by that? They'll still be reliant on utility generated energy supply for part of the year, but throw a solar energy panel system on the roof into the equation during other parts of the year, they can be contributors to the grid, with the net result of being energy neutral. Examples of effective R values now required in the National Building Code are expressed in RSI. Minimum RSI requirements are based on heating degree days of a building's location. Alberta is covered by Zone 6, 7A, and 7B, depending on where you're located. RSI values in this table take into account any thermal bridging that may be occurring depending on the assemblies used. This is what happens when you pursue net zero without focusing on the envelope. You can't just build a bigger solar panel to offset the energy consumption of an inefficient building assembly. So what does a net zero ready building envelope really look like? Of course, this is only a general prediction. We've not seen the 2020 building code yet, although it's due out the end of this year, nor do we know if they'll keep up with the ambitious pace that's been set when they're reissued in 2025 and 2030. Plus, there'll be numerous trade-offs and there are multiple climate zones, but this is a good starting point to use for planning. Of course, the biggest potential source of heat loss is through the roof and the windows. But we've grown accustomed to using all areas of our homes as living spaces, and we want the comfort and efficiency to go along with that mandate. To get there, we're going to need thermally insulated elements of the order of R60 to R70 ceilings, R30 plus walls. That's about double your typical 2x6 R20 bat assemblies that we've become accustomed to of late. More and more of us are making use of the living space in our basements. Almost gone are the days of unfinished basements with use limited to rumpus rooms for kids, storage for seasonal and retired articles, and laundry rooms. To work in harmony with the rest of the building envelope, they're going to need to run R25 to R30 range or more, and no one will want their feet resting on an uninsulated concrete slab. Radiant slab markets continue to grow on an annual basis for foundation slabs and slab-on-grade flooring systems. At the very least, they're going to have to be insulated to R10 to R15. Triple glazed windows have been an option that's been embraced for some time now, particularly when homeowners are faced with replacing an aging furnace and they choose to add air conditioning to the package while they're at it. Finally, everything needs to be airtight to minimize energy loss through multiple air exchanges. The goal is to have less than one air exchange per hour, and this can be achieved with effective heat recovery ventilator systems. We know as builders today that the ultimate level of quality and service delivered by building assemblies is the net result of a series of approved materials installations by qualified tradespersons. Just remember, when you increase the thermal performance of the building envelope, the movement of heat, air, and moisture must be managed. In trying to achieve improvement in thermal performance, often unintended consequences are encountered. It's not as simple as building the walls a little thicker and adding more bat to slow down the rate of heat loss, especially below grade. Moisture is present and condensation can lead to the formation of mold. Insects are close by and may decide to inhabit this more appeasing environment. Soil gas can enter And codes are evolving of late to mandate that we seal our foundation floors to prevent the ingress of things like radon gas. Concrete surfaces may be cool, causing condensation, and sources of moisture may be entering through random cracks in foundation walls that haven't been properly sealed. More bad insulation can actually reduce drying potential, causing condensation to occur year-round. Poor house wrap insulation further exacerbates this problem above grade, especially if it's not repaired and joints taped properly before the next trade applies the exterior cladding. All of these factors can lead to the building science tipping point and result in comfort and wetting risks that can produce serious indoor quality issues, making some buildings uninhabitable. Many of these risks have been mitigated through training and experience as we continue to move in the direction of sustainable construction. But no one expected a pandemic, and all the limitations it has placed on material supply, and now the rise in demand for new construction associated with sustained low interest rates, and the reset of many individuals' perspectives of what constitutes work-life balance. All of these have caused major spikes at every level of business as suppliers try to keep up with an explosion of pent-up demand. Early 2021 has seen unprecedented spikes in materials costs, although some of that has subsided of late. The question remains, where will it go next? Like many building materials over the last 3 decades or so, lumber has seen its peaks and valleys in demand until the last 12 months, where supply has not been able to keep up with demand, and the latter has been unprecedented. As little as a year ago, $50,000 could purchase enough lumber to build about 10 average size 2,300 square foot single family homes in the United States. A year later, that money will only supply enough lumber to build 2 of those same sized homes. Although some relief has come as countries start to reopen as they get ahead of the pandemic, but with the evolution of COVID variants and the anticipated vaccination rate timelines extending into the latter half of this decade, builders are going to need to consider all the options available to stay in the industry. So what does ICF offer the building industry? For starters, ICFs provide a scalable building envelope solution from the footings to the rafters. It provides a system of continuous insulation with no thermal bridging that delivers effective thermal performance to meet and exceed the evolving building code requirements for all climate zones. It allows us to achieve the air tightness goals of net zero energy ready without the risk of unintended consequences of trying to balance heat and moisture in doing so. ICF offers enhanced occupant and owner comfort through sound attenuation while providing a structure that will withstand the forces imposed by present and future climate conditions. And finally, of significant importance of late, ICF provides a materials supply chain alternate that facilitates faster year-round construction with reduced potential disruptions facilitated by fewer components than traditional building assemblies. Let's take a look at a typical decision-making process when a builder is considering an alternative supply chain. A home builders roundtable was conducted in 2017 where builders were asked what their top 5 concerns would be in deciding to break from their traditional construction practices. Number 1 in the forefront of every builder's mind is the costs associated with something new or different. Keeping housing affordable is for most builders job number 1, and most building owners want something that will retain value and minimize operating and maintenance costs. So material and labor costs sit at the forefront of most builders' decision-making processes. The owner wants something that's relatively competitive from a first cost point and definitively comparable or better from the standpoint of operating costs and value retention. Builders want assurance that anything they consider won't extend their exposure to any added risks over the long term. Builders grow accustomed to the teams of trades they've assembled over the years and want to know what implications a new way of building might have on how this team functions going forward, including any training that they may be needing. Will a new building system make the construction process quicker or easier or both? And finally, putting all potential benefits to all stakeholders aside for a moment, will this new system be overwhelming in any respect? Insulated concrete forms are high-performance building technology that offers built-in savings, resilience, and comfort. ICF construction is also faster and less expensive than you'd expect high-quality concrete construction to be. A typical ICF form is comprised of 2 EPS foam panels measuring 2.5 inches thick, 4 feet long, and 16 inches tall. Polypropylene webs, spaced at 6 to 8 inches apart, hold the ICF form together and act as the placement mechanism for both the reinforcing steel and for the attachment points for finished materials. A top and bottom interlock holds the successive ICF forms together. Cut lines, usually spaced a convenient nominal inch apart, allow cuts to be made easily, which in turn allows the interlock mechanism to function. Cutting anywhere other than along a cut line creates a stacked vertical joint. From a cost standpoint, looking at the two principal components of ICF wall system, concrete and the EPS ICF, pricing has been fairly stable over the last decade and has reflected the supply-demand evolution of most consumer commodities and products. When it comes down to it, most builders are looking for effective and reliable solutions that balance opportunity and risk to provide affordable and functional living and working spaces for their clients for the present and foreseeable future. ICFs deliver on those expectations, both above and below grade. ICFs simultaneously achieve 6 construction steps at once: concrete, steel reinforcement, insulation, air barrier, vapor barrier, furring strips, and attachment points. This inherently high level of efficiency significantly improves the speed of construction and eliminates labor costs. This is why ICF construction is faster and less expensive than high-quality concrete construction is typically perceived to be. Who should install ICFs? ICF manufacturers will train your current crews, allowing you to retain your preferred trades and potentially keeping them busy year-round. Even in winter climate conditions, ICF provides the insulation you need to pour concrete in winter temperatures with only minor insulating tarp protection required at the tops of the walls during initial cure period. ICFs allow you to keep your jobs on schedule no matter what time of year. ICF requires no new or additional subtrades. Your framers and cribbers can easily learn ICF installation and can start to fully realize the efficiencies in doing so from the first project forwards. ICF speeds up subtrade coordination, which means the building envelope can be closed up early, providing access to interior finishing trades sooner. Even before the recent surge in lumber pricing, seasoned ICF builders have been realizing all the benefits of the system at costs similar to or less than constructing equivalent thermally efficient building envelopes from metal or stick frame and insulating assemblies. Monolithic ICF walls with cladded interior are inherently airtight. Here's an example of ICF effective thermal performance. This ICF wall assembly does not include the exterior veneer, which will add to the assembly's effective thermal performance. Note the additional thermal performance that can be achieved when we kick it up a notch with graphite polystyrene ICF. Graphite enhanced polystyrene, or GPS for short, increases the wall assembly's R value by more than 15% without increasing wall thickness. The silver gray GPS foam is comprised of many small pockets of air within a polymer matrix containing graphite. The graphite reflects radiant heat energy like a mirror, increasing the material's resistance to the flow of heat, or R value. ICF wall assemblies with GPS typically offer an R value of about R28. Foam insert panels are also available. ICF wall assemblies that use additional foam inserts typically offer R values in the high R30s. These values are expected to meet and exceed the thermal performance requirements of the National Building Code in 2030 in all climate zones. Some builders would challenge that this scalable effective thermal performance can be achieved by incorporating extruded polystyrene, or as it's better known, XPS thermal insulation into traditional wall assemblies. But EPS ICF forms deliver this performance with a far lower global warming potential. As we look at the thermal images of two similar sized homes built next to one another under the same climate conditions, take note of the severe energy loss from thermal bridging throughout the wood frame walls, and conversely, the virtually complete absence of thermal bridging in the ICF walls. ICF walls are a natural match for effective thermal performance requirements. In addition to this level of energy efficiency, there are a number of other important benefits delivered by ICF construction over the lifetime of a home or building. For instance, ICF walls can easily be detailed to deliver a sound transmission class, or STC, rating of 50 or more. Conversely, it's quite difficult to design a wood frame wall to an STC greater than 50. In a multi-residential building particularly, privacy is very important to residents. This is why ICF constructed demising walls are very common in multifamily buildings. Also, drafts and cold spots are typically eliminated in ICF envelopes, and humidity is easily controlled in warm and moist conditions, thereby enhancing occupant comfort. ICF walls do not off-gas, and ICF wall assemblies do not contain any nutrient source that would support mold growth. The result is a very high and healthy level of indoor air quality for occupants. The disaster resilience of ICF-built homes and buildings is another incredibly important component of the ICF value proposition. The expanded polystyrene and steel-reinforced concrete composition of ICF wall assemblies means that ICFs are extremely resistant to damage from high winds, fire, earthquake, and floods. ICF checks all of the boxes for building solutions from footings to the rafters. ICF provides wall construction both above and below grade. ICF is cost effective and easy to install. ICF provides scalable high-performance R values and continuous insulation with no thermal bridging, delivering effective thermal performance that meets and exceeds evolving building code requirements in all climate zones. ICF facilitates construction during any season of the year. ICF meets building code air tightness requirements. ICF is very forgiving, allowing builders to avoid any unintended consequences. ICF enhances owner and occupant comfort and satisfaction. ICF is strong enough to withstand the current and foreseeable effects created by climate change. And finally, ICF provides an alternate supply chain option for construction. For more information on ICF, please contact any one of our member ICF associate member producers.